All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 86 is on the screen. Let's get started, please. That shouldn't take you long. And right after, get a Cornell note ready. You do need a prayer model. We're moving on. And also make sure you turn in your home plate from last night. We'll go from there. Copy and go. All right, check with the neighbors, see what they got for number one. We need to get started so I can call on someone. Number one. What you get for number one? Diego Rosas. Slope-intercept form was what? Okay. Okay. Steps? Subtract 12 from each side. Oh. So that gives us negative 3y equals negative 6x minus 12. Divide by negative 3. So we end up with y equals positive 2x plus 4. Yes? This is slope-intercept form because it looks like this. Y equals mx plus b, where m is the slope and b is our y-intercept. Hands, have you got that? All right? Yeah. All right. Number two. Number two, the graph for a quadratic parent function looks like this. I'm bringing it back. There it is. However, this transformation gives us a new vertex for it. What's our new vertex, please? Tell your neighbor before I call on someone. All right, new vertex. Who haven't I called on? Oh, Joel. 5, 2. 5, 2. So at 5, 2, which is over here, that's where we're going to move the entire function. There it is. All right. Number 3a, I need factors for 3a. Tell you what you got before Joel passes it to someone. Factors for 3a. Joel, pass someone. Hands, have you got that? Looks about right. All right, let's go to 3b. 3b, show your neighbor 3b, what you got for those before Jalen passes them to someone. Factors for 3b, what you get. This one you can use the shortcut or you can do the grouping. All right, Jalen, pass someone. That is correct. Hands, have you got that? Let's go. Let's go. Number 4, synthetic division. Remember, we need the coefficients, the constant, and this one needed to be solved for x. So therefore, you have 2. Then we got 3, 16, and 5. And the rest is history. So what is your quotient for that one? Share with your neighbor, see what you got before Alyssa pass someone. Alyssa, pass someone. What do you say that? What'd you get?
3x plus 33 plus 49 over x.
Let's go. That is correct. 3x plus 22 plus 49 over 22. My goodness. All right, and last but not least, We need to solve this system by substitution. I'm going to get it started. So I'm going to take one of the two equations, solve for one variable. I'm going to take the top one and solve for y. So I subtract x, I end up with, this becomes y equals negative x plus 3. So I no longer use that one. So it's called substitution because we need to substitute into the second equation. Instead of y, what am I going to write? All of that. So I write x minus parentheses equals 1. And now we're going to substitute negative x plus 3. Distribute, so we end up with x plus x minus 3 equals 1. Combine like terms, we get 2x minus 3 equals 1 plus 3 plus 3, 2x equals 4, divide by 2, x equals 2. Am I done? No, because now we get a coordinate, now we need a y value. So which one do you want me to use, the second one or the one in red to substitute the x? The second one. No, I'm going to use the red one. So y equals minus parentheses plus 3. And instead of x, I'm going to substitute 2. So this becomes y equals negative 2 plus 3, which is 1. This is my solution. But what does that mean? Tell your neighbor, please. What does that mean? Solution. What does that mean? What does that mean, Dylan? All right, let me write it again with big point of intersection of what? Of the two graphs. That's what the solution means. All right. Copy the agenda, please. Warm-up 86, system of equations. Home play is pages 197, 198. From there, make sure you go and turn in your home play from last night, 6 problems, and get a Cornell note ready. You do need a fair model. I'll give you some time for that. Copy and go. All right, here we go. Our objective for today, I can solve a system of equations, which today is linear and quadratic. No longer baby systems that we've been working on the warm-up. That's easy, Mr. Q. Oh, yeah. Piece of cake. Good thing we practiced, yes? So, we're moving on to funner and better systems, which is linear and quadratic. And quadratic, they're going to include, of course, parabolas. And also the other one, which we've been seeing from time to time, which is circles. However, before we get into our Freyer model, our main concept is systems of equations. Just to recap from your Algebra 1 course, there were 3 ways of solving systems of equations. The 3 ways were by graphing, by substitution, and by elimination. You guys remember that? Yes? Of course, some of you that were with me, let's see, are there any left? Not in this class. When I cover these, I had you do all 3 of them at once and together. So we've been working with graphing and substitution. We still haven't really hammered elimination. We're going to get there again. But today we're going to continue with substitution and graphing. Okay? So, with that said, also, we've worked with quadratic equations. Look up. Don't copy this. 5 ways of solving quadratic equations are, the first one, completing the square. Have we been working with those? Yes. How about quadratic formula? You guys remember that one? Yes. How about square roots? Yes. How about graphing? Yes. And the last one, by factoring. Have we been using those? Yes. But which one did you rely the most on? I think square roots, right? Some of you like that one the most. However, today we're going to be using a variety of those forms. So For home plate, just keep that in mind, these 5 different forms. So with that said, in your Freire model, write this down. Systems of equations. What are they? Definition. The set of 2 or more equations that have the same variable. The set of 2 or more equations that have the same variable. The set of 2 or more equations that have the same variables. Example. Let's see. Is that 2 or more equations? Yeah. Y equals x squared plus 5x plus 6. Then x minus y equals negative 3. Those are 2 equations. Okay. Do they have the same variables? xy, yes. Another example. Y plus 3x equals 0 and y minus 6 equals negative 3x squared. Are there 2 equations or more? Yes. Are they the same variables? Yes. How about all 4 of them together? Is that a system, guys? All 4 of them together? Yeah, because the definition says 2 or more. Okay. Do they have all the same variables? Yes, it is a system. All right. So as you're copying that, look at the none example, though. Tell your neighbor why this one is not a system of equations. Why is that not a system of equations? All right. Why is that not a system of equations, Jaden? What? They have different variables. So therefore, what would be our first hashtag, everyone? Hashtag what? Same variables, yes. The second hashtag should be 2 or more EQs, or 2 or more equations. All right? So once again, as I said today we're going to focus on 2 different ways of solving systems, on substitution and graphing. So with that said, underneath that, copy example number 1. It says solve the system by substitution and graphing. System given, y minus 6x equals x squared plus 5, and y minus x equals 1. So, they want us to solve the system both ways, by substitution and by graphing. So for right now, I'm not going to worry about the graphing portion. Let me cover that up. And I'm only going to focus on substitution, which means we're going to be doing a lot of algebraic stuff over here. So let me zoom in. All right, there it is. All right, so we're going to do this one together, and I'm fairly confident that you will be able to follow along. We've been having plenty of practice on the warm-ups. So look at it. Do we have 2 or more equations? Yes. Do they have the same variables? Yes. So in order to solve by substitution, look up to the screen, one or the other need to be at least solved for 1 variable. Is this one solved for 1 variable? No. Is this one? No. But which would be the easiest to leave by itself? The bottom one, is that correct? What do you want me to solve for, the y or the x? The y. So I need to leave y by itself. So what would I do here to leave y by itself? Everyone? Add x. Do that together with me. Add x. So my new equation is y equals x plus 1. So now we can actually substitute this equation into the first one. What do you mean, Mr. Q? Yeah, here instead of writing y, tell you never what we're going to write for that equation, x plus 1. So with black, draw an arrow that we're bringing that equation down, this one. So I'm going to write negative 6x equals x squared plus 5. And instead of the y, what do I write here at the beginning, everyone? X plus 1. That is correct. So up to right there, is everybody following? Yeah? Fairly simple? All right. So let me move this up. And that brings us there. All right. Let's simplify the left side. Let's do that in blue. Can we combine stuff? Yes. What is x minus 6x? Negative 5x. Bring down the plus 1. And all that equal to x squared plus 5. All right. So we need to solve that equation. What kind of equation do we have? It's a quadratic. So let's think back when we solve quadratic equations. What is the first thing that needs to be met? That needs to be in standard form and equal to what? Standard form and equal to what? 0. So we have x squared on this side. How can we make the other side 0? Tell your neighbor, please. What can we do here to make this side 0? Anaya, what can we do? Add 5x and subtract 1 to each side. Add 5x, subtract 1. We're left with, this cancels, 0 equals, bring down the x squared, bring down the 5x. And what is 5 minus 1? That is 4. Now your brain should start thinking as to what would be the next step here. Talk it over your neighbor. If we have a quadratic trinomial like this, what can we do here? Talk it over your neighbor. What can we do there? Diego, Romo. That is correct. Factor 4 and 5. Factors of 4 that add up to 5, everyone. 4 and 1. I'm going to do that in blue to show the next step, which means my factors are x plus 4, x plus 1, and all that equal to 0. You're like, oh snap. We know what to do next. Tell your neighbor what to do next right there. Juan, go. Diego Rosas, what do we do next? We what? We have this times this equal to 0. Therefore, set them equal to 0. X plus 4 equal to 0. X plus 1 equal to 0. And then we solve. All right? So, minus 4 minus 4. X equals to negative 4. Minus 1 minus 1. X equals negative 1. All right. And underneath those, I'm going to write those in green. Check this out. Negative 4 in a parentheses by itself, and negative 1 in a parentheses by itself. Why, Mr. Q? Well, let me go back to the top. Let me zoom out. We started with a system, didn't we? When we find a solution to a system, it's actually in a coordinate, right? We have the x, but this time there were 2 x's. And now we need y values. So look at it. Scan through. What can I do with these x values to get their y values? Talk it over your neighbor. What can I do over here to get my y values? Talk it over your neighbor. What can I do? All right. Good conversations. Jessica, what can we do? Let's go. So you would use the y equals x plus 1. I'm going to bring that down. Y equals x plus 1 and do what? Let's go. Substitute each value. I'm going to start with this one, the -4. I'm going to substitute it in here. So I get y equals -4 plus 1. So y equals -3. And we set each value. So I need to write it again. And now I'm going to substitute the value of -1, -1. So therefore, y equals to 0. Now these are my what? Solutions. All right, tell your neighbor what that means. What does that mean? What does that mean? Dylan. Points of intersections. What does that mean, guys? That means that if we graph these two, that's where they're going to intersect. We've been working with these on the warm-ups. Make sure it sticks in your noodle because you need to understand that. So let's plot our solutions on the graph. Let's see where they're at. -4, -3, -4, -3, -1, 0. We're predicting that that's our solutions, that when we graph the other ones, that's where they're going to intersect. All right, so we just finished solving using substitution. From 1 to 5, I'll come through you with that. From 1 to 5. 5, 5, 4s, 1, 3, 4s, 5s, okay. All right, so we're done with substitution. Now we're going to solve it again, but now we're going to solve it by graphing. Because tonight you're going to be asked to do one or the other. So here we go. So by graphing, I want to write our system again over here on the side. I'm going to write it again. However, now both equations need to be solved for y. The bottom one is already solved for y. Is that correct? Yes. So I write it y equals x plus 1. However, the top one, let me zoom in. We need to solve this one for y. What shall I do? Tell your neighbor. We need to leave y by itself. What do I do there? Delilah. Add 6x to each side. That is correct. So my new equation is y equals x squared plus 6x plus 5. All right. So now that we have this, by looking at it, tell your neighbor which is the easiest one to start graphing now. Which one's the easiest one to start graphing now? All right. Easiest one to start graphing now is which one, Fabian? The bottom one? All right. So let's graph the bottom one. Let me zoom out. So if we graph the bottom one, where do I start, everyone? Circle the positive 1. That's my y-intercept. Place it there. And then we need a slope. So what number is the coefficient of x, or the number in front of x? It's an invisible 1. We need that in fraction form over 1. That means 1 up, 1 to the right. Plot your point. Do it again. 1 up, 1 to the right, plot your point, do it again. 1 up, 1 to the right, plot your point, do it again. And for the sake of to making sure that we have an accurate graph, look up please. I'm going to go back to positive 1 right here. Now I'm going to go the other way. Instead of going 1 up, 1 to the right, I'm going to go 1 down, 1 to the left. Plot your point. Do it again. One down, one to the left. One down, one to the left. One down, one to the left. Graph your line. And what do you guys notice? That it's already going through those 2 points that we came up with. So far so good, yes? Alright, so we're done graphing the linear. Now we need to graph the quadratic. How do we graph that? Simple as bread and butter, getting a table going. However, look up please. Instead of me using from -2 to 2, look at the 2 possible solutions. They're between what x values? -4 and what? -1. So my domain, I'm going to go 1 for each side. I'm going to start at -5 and go all the way to 0 on my table. From -5 to 0 on x. So, let me zoom in over here to make my table. Here we go. Make a table, x, y, and we set the domain from -5 to 0. -4, -3, -2, -1, 0. Oh my goodness. All right, so we take our equation, this one, and let's substitute our first value. What's our first value? I'm going to do that in blue. -5. So, what is -5 squared? 25. What is 6 times -5? -30. Bring down the +5. Combine like terms. 25 plus 5 is 30 minus 30. 0. There it is. Let's do it again for the next value. Y equals parentheses squared plus 6 parentheses plus 5. So, let's see. -5, oh no, my bad. -4 is my next value. -4, -4. What is -4 squared? -4 squared is 16. 6 times -4, -24. Bring down the 5. Combine like terms. 16 plus 5. 21 minus 24. -3. Let's do it again. Y equals parentheses squared plus 6 parentheses plus 5. Next value is -3. -3 squared. 9. 6 times -3. -18. Bring down the 5. Combine like terms. 9 plus 5, that's what? 14 minus 18. -4. Do the next value. Y equals parentheses squared plus 6 times plus 5. My next value is -2. -2 squared. Four. 6 times -2. -12. Bring down the 5. Combine like terms. 4 plus 5 is 9 minus 12 is -3. And I don't know if you noticed, it's starting to curve. It's the parabola. We started with 0. It went to -3, then -4. Now it came back to -3. So guess what will be our next value? 0. Notice here, the 0 coming back. And for the last one, 0, look up. What is 0 squared? 6 times 0. And that leaves us with 5. All right, let's plot those points. Let's see. -5, 0. -4, -3. -3, -4. -2, -3. -1, 0. And 0, 5. Look at that beauty. My goodness. Let me move this up a bit. There's our graph. And what do you guys notice? Both graphs intersect here and where? There. Make it obvious. Point to it. And then write solutions. Why are those the solutions? Dylan. All right. Yeah, it's the point of intersection of both graphs. Look at this graph. Look at that graph. They're intersecting there. Did we get the same thing with algebra? Yes. There it is. From 1 to 5, I'll come through you with the graphing portion. 5 fourths, 5 fourths. Yeah, a little bit better because we've been graphing all year. So once again, for the graphing, make sure both equations are in Y form. The first one, you use slope-intercept form to graph. The second one, use a table. Just make sure you know where your domain is at. I usually go from -2 to 2, but if your solutions are going to be somewhere over here, so make sure you use the domain, appropriate domain. All right? So with that said, I'm going to give you one for you to do by yourself. Copy this one. Example 1Q. We got y minus 6 equals x squared plus 5x, and y minus 3 equals x. And I'll give you some time. I first do substitution, and then from there go to graphing. Oh, sorry. All right. Copy and go. All right. So example 1Q on the screen. Check your work. We got -3, 0, -1, 2. Let's go. Let's go. And then I started by graphing the first one, y equals x plus 3. There it is. And for the second one, what domain am I going to use? Well, it's going to be between -3 and -1. And I'm going to go one more, so it's going to be from -4 to 0. That's how you graph the other one. And I'll have you do that by yourself. All right, I'm going to stop the video right there. The rest of you finish up, please. And that's pretty much the home plate, okay? Enjoy your home plate. Those of you are watching on video. Bye.